All right. So there are a lot of activity in this new area called LPWAN, Low Power Wide Area Network. These are all the things that I could find. All right. Luckily, one of them stands out so much that I had to present to this class, LoRaWAN. The reason it stands out to me is that I went to this IoT World Forum in Dubai last whenever, and December actually, yeah, and IoT World Forum, and Cisco arranged it. 2,000 big, like CIOs. You name the company, GE, all the company, IBM, all their CIOs were there, and everybody else. They took us on a tour, showing us what a smart city will look like. Dubai is the smartest city in the world. At least in that time they said that. Okay, so, and then they showed us, they took to their smart park, a new city where they're building, and they said, oh, this is LoRaWAN. And I had not heard of LoRaWAN then. So I said, okay, well, I got to figure it out. So LoRaWAN is there in the sense that it is being used, and Cisco is a member of the LoRaWAN Alliance and LoRa Alliance, and all the big companies are member of this. It's not, basically it's a mixture of both standards and proprietary thing, but it is going very fast. And it could have, there are two things that can happen in the future. It could have a future like Web HD, and that was whatever HD it was, right? And 60 gigahertz thing where it was alive in 2009, but not alive in 2015 anymore because 11 AD came in. So LoRaWAN is alive right now. Right now, if you want to experiment with any long distance thing, you have to have LoRaWAN is the only choice. Not the only choice, is the main choice. Is a good choice, okay? Whereas 11AH is not there. So two things can happen, that 11AH will be so late that nobody will care about it. LoRaWAN will be firmly entrenched. Or IEEE could wake up and say, look, we got to push out the standards faster than what we do, and then LoRaWAN would be gone. Okay, with that, I'm going to tell you about LoRaWAN. Long Range Wide Area Network. So it was developed by a company in France, a small company, which was bought by Sematech Corporation, and they knew that everybody knows nowadays that you cannot sell anything proprietary, so you have to have a group of company around you. So they formed the LoRa Alliance, and LoRa Alliance has 160 members. And the standard just came out in January 2015. But products are there. So I went to Amazon, and you can buy an Arduino Radio Shield for LoRa. You can buy, for Raspberry Pi, and so on and so forth. And in fact, I might even be experimenting with these. Because it is a long distance, much longer than 11. And it is there. You can buy it today. You can play with it today. And actually, I saw it working. So that was another big thing. To see it in a demo where we are driving, and the building over there is LoRaWAN, and we could see the effect. Okay, that was very powerful. All right, so rapid adoption products are already available on Amazon, and these are very cheap, by the way. So this is something that if you want to play with, and these things are sub $100, less than $100. Bidirectional communication. So it not only that you can use it to collect the sensor information, you can also update the sensors. Okay, so if you have to do any firmware update, meter update, or whatever, it can do both ways. Of course, it is very low rate, 0.3 kilobits to 22 kilobits in Europe and 0.9 kilobits in US. Every country has a different rate because every country has a different wavelength. Every country has a different band, size of the band, bandwidth. And every country has a different rules for what you can do with that bandwidth. The topology is stars of stars. Now again, that you notice that this was in 11AH. Zigbee went a bit too far with mesh, and I don't think mesh is succeeding. So they are kind of, trees of trees, we said, stars of stars. So that's what they do here, stars of stars. And so basically with one level of relays, which are optional. Now there are two pieces of information here, that there is a gateway and there is a server. Okay, it is difficult to say which one is the access point. They have a different function. So actually the function is coming in the next slide, so I will hold on to that one. But notice that this one shows a wireless, this thing, and this one doesn't have wireless. So server is somewhere in a room connected by wire. The wireless part is called gateway, and the server is the real brain, of the whole thing. And of course, the gateways can talk to all the devices, or if they need to reach some devices, they can reach through the relays. So that's how it becomes trees of trees. And security-wise, each one has a key. The key size is 128-bit for the devices, 64-bit for the network. So what is the network key? Before you can participate in a network, you need to know its secret, right? I mean, like I have my certificate, I have my keys, but I can't just go and join a meeting. Let's say in the chancellor's office there is a meeting going on, right? So I need some secret to be able to get into that meeting. So that is network key. So this is 64-bit and 64-bit application key. So you join the network, but you can't just go and start reading or writing the electrical meter reading. You have to be part of the electrical company. So that is the application key. So this is another new concept, actually, basically, is that you just don't need one key. Right now in your home, when you program a network, you put the key and then you are free to do everything. You can print, you can play music, you can look at the files, which was yesterday good, but not good anymore, right? One of the workers who came to my house and said, can I use your wireless? I have a problem, because if I give her access to wireless, she can see everything, right? So I have to immediately create a new wireless guest network and give her that, so that she cannot access my files, but she can access the internet, right? So now that application is allowed, but printing is probably not allowed. I don't know about printing part, things like that. So now the thing is, now you have to have keys for everything, for every privilege that you want, every application, network, and yourself. So there are three classes of devices: uplink transmission followed by two short-linked downlink, schedule determined by the endpoint, which are simple devices. So basically, class A is that whenever you transmit, you are given, you can receive up to two things downstream. Okay? And that's it. You cannot receive any other time. When you next time you transmit, you get two more things to get down. Okay? And so the devices are very simple, and it's all pure Aloha. Now remember, LoRaWAN is before 11AH. Right? So there are some features in 11AH which are not there in LoRaWAN. So it's pure Aloha. Pure Aloha means contention, basically. You just contend. And it works okay if your load is low, and that's what they assume, that the load is low. If the load is high, then a long time ago we did the analysis. Everybody did the analysis. Back in 1980s, it was kind of common for all the academics to do analysis of contention. And Aloha is known to have performance of 1/2E. Right? E is 2.7. So 1/2 is 18%. That is efficiency under heavy load. Gateways listen to multiple transmissions on multiple channels, and all gateways listen to all transmissions. So that's another thing. There is not one gateway. Okay, so this I should have pointed out in the previous slide, which I didn't. Maybe I will change that slide. Is that gateways could be many gateways. So I could put a gateway here in that building and that building and that building along the road, and you can talk to any gateway. Right? Gateway is not the brain. Gateway is just going to receive your thing and give it to the brain, and the brain is server. So everything will go to server, and server might even get multiple copies, because multiple people listen to you and then they send it to the server. So the access point, so this is another thing, is that they divided the access point function into two functions. One is the radio function and one is the non-radio function. Right? The radio function is in the gateway and there are many copies of it. The main function is in the server, which is somewhere else. So all gateways listens to all transmission. So there is antenna diversity by design. So you're transmitting to 4 antennas, and from your one antenna, there is already 1 to 4 streams, right? So you get that, and then whatever is the strongest transmission will have the best reception. The server will know, and then server will tell the gateway, now you are the one who is going to do the downlink one. Okay, so you won't get 5 responses back, you will get only 1 back, even though you send to everybody. And so this allows mobility. Yeah, question.
It says a 2 short downlink.
2 short downlink, yeah.
So the second one is like from another gateway, or?
Okay, so very commonly, downlink is nothing but the acknowledgement that I got it. Most commonly, okay? Now, the thing is, sometimes I do have to send you, like, for update or whatever reason, I have to send you some information, right? So that's why it doesn't say just acknowledgement. And it's not just 1, it is 2 short downlinks, which could be, very small, could be just ACK. Right? Yeah, so no. So, okay, so that's a good question as to why you need 2, why not just 1 downlink? But I think the idea was that one could be that I got yours, and then maybe another information, which is not really an ACK. I just said 2 ACKs, I made it up actually. I don't know really why the second ACK you need. You need only 1 ACK. But the second one, two downlinks, because that is the only time you can receive. Class A stations can receive only when they are up. Otherwise, we assume that they're sleeping. Okay? So, for example, if I want to send something to you, or to somebody else, let's say, and they're sleeping, I cannot do it. At the access point, the server cannot do it. They will wait until you transmit something. Okay? It could be maybe a null data packet. I don't know whether they have null data packet. Whenever they transmit something, then I can send you 2.
When you talk about IoT, you're talking about like really low data rate, and I believe the communication is going to be in sync. So why don't we use slotted LoRa instead of LoRa?
Sure. So now you're going. See, thing is that I put these things in the wrong order. This technology. So they use the slotted LoRa kind of thing, right? First of all, 11AH did slots. Not only they did slotted LoRa, which is just putting the slots makes it a slotted LoRa. Second thing is they did segmented slotted LoRa. They put people into segments, right? So those are all new concepts. A slotted LoRa is not that new concept actually. I agree with you. A slotted LoRa was done in 1980s. What is slotted LoRa is that LoRa means you can just do anytime transmission. So that was the original protocol. By the way, LoRa protocol, for some of you who, I'm sure everybody tells you these stories when they teach you this. But LoRa was done in University of Hawaii. That was the first radio network in the world. Okay? And the problem was that they could not put wires. Why they could not put the wires? If you have been to Hawaii, there is hundreds of islands. You cannot put the wire, right? So the only way they could communicate is by wireless. So they said, okay, why do make it complicated? Just the simple rule. Whenever you want to transmit, just transmit. Done. That is Aloha protocol. Okay. Aloha is hello in Hawaiian. So basically, that's the protocol. You can say hello anytime you want. And there's no other rule. So that was Aloha. Then people said, oh, it's 18%. So it's not very good. So then they changed it to a slotted Aloha. Not they. Somebody else probably came up with the idea of slotted Aloha, which says that, okay, so we don't do it anytime you want. We will have time windows. So everybody's clock is synchronized, and there are time windows. And so then you speak in a slot. If if you don't do that, then go to the next slot and not in between anywhere. That improves it to, I think, 1 upon E, just from memory. I don't know exactly. It improves a factor of 2. Okay? And on and on. And so hundreds of papers on this whole CSMA CD is still coming on, 30 years later. But so the point is good. But these guys, for class A, this is simple. Basically, you wake up, send it, multiple gateways. Here what protects them is that there are multiple gateways. You might collide. Let's say if I and her speaks together, maybe I will collide here, but not collide there, or maybe she will not collide there. Maybe they will both get through. See? So anyway, class B stations, they do class A plus. They have a scheduled time like a RA, like the restricted access window. So when the beacon comes in, at the beacon, they can get a reserved time and they can send it at that time. So this is people who have more to send. And class C are even more powerful stations, which have some electrical power and they don't go to sleep too much and they can receive anytime. You can just send them whenever you want. All right, so people, class A, mostly sleeping. Class B, kind of, sleeping at a scheduled point. Okay, and class C, almost always awake.